Microgrid project. Before we introduce the speaker, some housekeeping. Audio is muted for everyone, but you can please type in your questions through the chat box on the right, and we will look to answer those following the presentation. So just next slide. Today's presenters are AJ Esquega from the Gull Bay First Nation, Shawn Bremner of OPG, Peter Bright from Stantec, and Kevin Ritzman of Alltrade Industrial. So it's my pleasure now to turn things over to AJ Esquega. Over to you, AJ.
All right, miigwech, Justin, thank you very much. AJ Esquega, an indigenous cause, Kashkizaging and Donji. My name is AJ Esquega and I come from Gull Bay First Nation. And I'm going to speak today about our project, the solar Giza's Energy Solar Energy Storage Microgrid project. And as my Nokumis, my grandma would say, you know, when I see her speak, she says, have an open heart and an open mind, and take what is, you know, going to benefit you, or take what's good for you. And you know, if it's not going to work, then just leave it. So I asked in the same manner, you know, take what's good for you. And I also sharing from my perspective and my role as the Microgrid Energy Projects Coordinator in this presentation. Also acknowledge that I'm speaking on my community's territory, Kashkizaging, within the Robinson Superior Treaty Territory. And I acknowledge that, you know, everyone tuning in, speaking from the Indigenous, the Inuit, Métis, and First Nations lands that you're sitting on. Acknowledge from coast to coast to coast. So without further ado, I'll start the presentation. My community, Kashkizaging, is 2 hours north of Thunder Bay on the western shoreline of Lake Nipigon. It's an Ojibwe nation, and its original signatory is mentioned to the Robinson Superior Treaty Area. And there's about 375 people living in the community and the current reserve boundaries, and about 1,025 living outside the current reserve boundaries. If you want to kind of picture how the community looks, there's about 97 residential homes and 13 community buildings, which now includes 14 with the solar Giza's Energy Storage facility. And we have been on diesel since the 1960s. So this project is, you know, paving our way for a clean energy future. How did it all started? How did we get here? Well, there is kind of a story about it, and it's from with reconciliation with OPG. And there was floodings on Lake Nipigon back in the 1940s, 1950s, all the way from the 1930s to 1950s. Several dams were constructed, which caused floodings on Lake Nipigon. And it caused our cemetery our shoreline to erode, and eventually our cemetery to go into Lake Nipigon. And there was no communication that these dams were being built. The community was left wondering what was happening. You know, why is our shoreline eroding? They had to go retrieve the bodies and rebury them into a new cemetery spot. So, and throughout those years, there was never really any reconciliation, no reason, no apology or anything. So until Chief Wilfred King and Council, when they got elected in, they sought to approach OPG and reconcile this past. And that's when they negotiated, you know, a settlement, and they had an apology ceremony in the community, both on reserve and off, and built that commemorative plaque that you can see behind them in the picture to commemorate this new understanding and new relationship moving forward. You know, these lands and waters have, you know, been the sustenance of our people since time immemorial. You know, we use the fish, the drinking water. They're kind of our highways back in the day when we were traveling. So this was our way of life, and it was severed and through the dams. But from moving on, they had the apology ceremony, and they wanted to work on a project, wanted to not just have an apology ceremony, but also work on reestablishing that relationship. And that's when we at the time wanted to build our community, wanted to grow. They thought, well, we need more power, you know. Since no power was provided to the community through the dams, why don't we start there? So they came up with the idea of solar, renewable. We want to get off diesel. Diesel does not, you know, mesh with our values. It pollutes Mother Earth. You know, it's dirty. So we wanted to get into renewables. That's when the OPG team in Gull Bay thought of the solar and the battery energy storage. Because we are one of 4 communities in the north with the study from the ISO, it just wasn't economic to build a transmission line to the community. So we had to think of our own isolated energy system. Solar microgrid seemed like a best fit. So once we got that, once we had the negotiations in place, they started looking for funding. Once they got the first bit of funding, then they started developing the team. And you know, that's when they hired me, and I became the official liaison, the Microgrid Wind Energy Projects Coordinator, which really Microgrid is your power, your strength. And when you go Microgrid Wind, that's channeling it with that inner strength that we all have, that inner strength of building your inner strength and building and resonating it. So I take that wholeheartedly, you know, and this is the start of our clean energy future, and I look forward to more clean renewables in the future here. What was our involvement? There was a lot of chief and council support. I had Councillor Kevin King there, you can see in the picture. He was my manager. I reported to him regularly, kept him in the loop. And if there was any chief and council decisions, I would address it with him, and he would bring up the chief and council, or I would provide a presentation and a chief and council update. The community was community driven, or the project was community driven. We had information sessions, both on reserve and off reserve. We had seasonal newsletters. We had a logo contest right off the get-go. We had clean energy bingo nights for the elders and the youth. We had clean energy jeopardies, and whenever there was an event, I was there, you know, with a booth with information material, and I also was in the community all the time for any questions that anybody had. You know, so I was supported. I also supported the efforts with writing proposals with OPG. We attended meetings. We attended, you know, the sessions to secure employment. So we worked together in there. We were also involved in the technical meetings and every project management meetings. Either myself or Councillor King was there. We also had Lumos Energy, Chris Henderson and Daryl Brown as our advisors. So we sought advice from them because we didn't know a lot about energy before this. So they had several years experience working in Indigenous communities and in the energy sector. So that was really helpful. And yeah, we had also involved members in the construction phases. I had interns working with me, learning what I was doing on a daily basis as well, so that I build that capacity up. So we start building the capacity in laborers and in knowledge, sharing that knowledge with our members in the newsletters and with the youth. In this project, it was a beautiful synergy that we all had. There was several, you know, collaborators in this. There was OPG, our project development partners. There was Hydro One Remotes, the diesel generator station, and there was ABB, Lumos Energy, Mars, Stantec, Alltrade, and you know, the list goes on. There was so much people involved. It was nice that we all worked together for this common goal to finish this project and provide some benefits to the community and overall to Mother Earth and the climate. We collaborated on the project development, the advisory, technical meetings. Whenever there was an issue, we had several people to draw from to figure out the solutions to resolve these issues, work together for funding, and work together like here today, showcasing the project so that we hope that other communities can benefit. Lessons learned. Well, we learned many lessons throughout this project. Nothing kind of goes perfect, as you will notice in some of the future slides with the other presenters. But we plan on sharing what we learned in this project to other Indigenous and remote communities looking to get off diesel, and or looking at solar energy storage as a project for their community. And Chief Wilfred King was just recently appointed on the advisory committee for the sustainable energy appointed from the Assembly of First Nations. So that just adds to our leadership in helping other Indigenous communities and helping the Canada to get off diesel and take charge and take the lead and getting cleaning up this energy landscape, cleaning up the air and cleaning up the water. If we keep going this way, it'll just get worse and worse, and we won't have much of a future for our future generations. We've got to make sure that we are paving the way for a sustainable future for our kids, your kids, and all the future kids that are, coming next after us. So I'm going to hand it off to Ontario Power Generation Shawn Bremner to share his slides. Miigwech.
Well, thank you, AJ. Thanks for that introduction. Hi, everyone. I'm Shawn Bremner. I'm a project engineer in corporate business development for Ontario Power Generation. I was involved in this project right from the beginning and still involved today in the operation of it. So sort of as AJ said, we're looking at the Independent Electrical System Operator in Ontario. They did a study looking to connect all the remote communities in Northern Ontario. The map to your right here is Northern Ontario. And there's 24 remote communities in the north. And the ISO did a study and decided that 20 of these were economical to connect to the transmission grid and get them 100% off of diesel. But there were 4, including Gull Bay here on Lake Nipigon, that they deemed they would not be connecting to the grid. So funding was set up for these communities to look at alternatives. How can we reduce diesel in these communities without connecting to the grid? And as AJ mentioned, OPG and Gull Bay First Nation had recently completed a reconciliation. And so we're starting a partnership with them. And we saw this as an opportunity to extend that reconciliation even further. So what we started looking at is, okay, what are the parameters in the community? So AJ mentioned the size of the community. So in the winter, the load's only about 300 kilowatts, and in the summer it goes down to about 150 kilowatts. Hydro One Remotes operates 3 diesel generators in the community to provide that power. They also maintain the local community grid or distribution system in the community. So working with Hydro One Remotes was key to, really integrating this new microgrid into the system. So as I mentioned, the drivers were continue on with our reconciliation. OPG and Gull Bay First Nation, we want to learn about microgrids. At the time, it was sort of the buzzword in the industry about microgrids. So we wanted an opportunity to plan one, design one, build one, and operate one to see what we could learn from this. Government funding became available. As I mentioned, there's different funding opportunities for both the federal government and provincial government. And then the real thing was, how do we maximize the penetration of renewable energy into this grid? 2 reasons for that. more energy, more renewable energy we put on the grid, the more diesel we reduce, and second, the more revenue the project would make. So this is a schematic of the microgrid connection. On the left here is the existing system. This is the 3 diesel generators that have been on site, like AJ said, since the 60s. And on this side is the microgrid system. We have a battery system and a solar PV system. And working with remotes, we determined that the best way is to really the true interconnection of the new system into the diesel. So this was basically treated as a 4th generator, connected at the 600 volt line directly into the Hydro 1 station. Our microgrid computer system, which monitors the load, monitors the diesel generators, monitors the battery and the solar production, is also directly connected to the PLC system in the diesel generator. This allows the 2 systems to communicate seamlessly, to work together to, and I have to say, Hydro 1 Remotes is very much on board with, like I say, maximizing the amount of energy we can get out of this renewable energy system to reduce their diesel use in the community. And so I say this is key, this true interconnection into their existing system. So OPG and Gull Bay First Nation, we worked together. We did a bunch of modeling up front of what we're going to build. We looked at wind energy, hydroelectric, solar, batteries. We looked at various different shapes, sizes, configurations, trying to get the most bang for our buck. How big a system can we build to meet the needs of the community without, overbuilding it and basically wasting a lot of energy and resources. So through this, we wanted to build a system that could power the community entirely on renewable energy. So meet that 300 kilowatt demand in the wintertime. So we ended up building was a solar array, 360 kilowatts DC, a battery system that's 300 kilowatts of capacity and 555 kilowatts of energy. The microgrid controller, which I mentioned controls the whole system. I'll mention here, we did our homework up front on previous microgrids that have been built and looked at what worked, what didn't work. And one thing that came out that we noticed was a couple things. One was this microgrid controller really being the key to being able to integrate different energy resources into the system seamlessly. So we went out and looked for a off-the-shelf product, proven operability that had worked in other systems that we could use. And we ended up going with an ABB controller, and basically we picked it first and then built the system out from there. The other thing we wanted to do is Gull Bay First Nation, in the end, is operating this system for the 20-year life we expect it to operate. So we wanted a system of all the components were basically off the shelf. We didn't want customized equipment that, in the future breaks down that you can't get parts for us. We wanted off the shelf equipment where we could. So that's where we ended up with this system. Through the modeling, the total load in the community is about 1.4 gigawatt hours. We predict we can produce supply about 450 kilowatt hours through the microgrid, which is about 32% of the load. And then this other item, this 2,200 hours of diesel off. This is the number of hours during the year we're going to shut the diesels down completely and power the community completely on renewable energy. This equates to about 130,000 liters of diesel fuel per year that will not be burned, which equates to approximately 400 tons of CO2 not emitted to the atmosphere. So how does the system operate? This is actual operating data that we collected from last year. Just quickly, the vertical graph is kilowatts. Energy above the line is positive, below the line is negative energy. The green line is diesel generator output. The blue is solar PV output, and the red is the battery. If the battery is below the line, that means it's charging. Above the line is discharging. So typically how this operates is through the night, diesel generators provide all the power for the community. Excuse me. Morning comes along, sun comes up. The diesels go to their minimum operating point, which is about 40% of whichever diesel's online. And then as the amount of solar energy goes above what the community needs, we charge the battery. So you can see the battery's charging. We have the solar contributing, the diesel's contributing. We get to this point in the day, in this case, it's about 12:20 in the afternoon, when the state of charge of the battery gets to 75%. 75% was chosen as a conservative number of when we have enough energy to take over powering the community from the diesels. One of the parameters is that Hydro One remotes did not want the diesel generators starting up and shutting down several times a day. They want one shutdown some point during the day and one start up later in the day. So we come up with this 75% number. So we get to this number, and our controller sends a signal to the diesel generator system, says we have enough energy to take over the power in the community. That gets confirmed, and the diesel generators shut down. So at this point, community's 100% on renewable energy. Solar continues operating as it will. You know, you can see here, this is sort of a cloudy, sunny day. Solar energy is going up and down through the day. When there's excess, we still continue charging the battery. When there isn't, battery starts outputting power. The other thing at this point is the battery is now forming the grid. It's providing frequency and voltage support to maintain the grid in the community. So as the day goes along, sun starts setting in the evening, amount of energy from the battery increases. At some point, we've actually lost all solar energy, but we have stored all this energy from earlier in the day. So we get another few hours of powering the community off that stored solar energy. We get to this point, and the state of charge of the battery is about 25%. And we send a signal back to the diesels to start back up and take over powering the community. And again, 25% was chosen as a number of give the diesels enough time to start up without risking a outage in the community. We don't want the batteries to go to zero and the diesel's not started and the community have no power. So this gives ample time for the diesel generators to start back up and take over. Next day, we repeat ourselves. And that's basically how the system is designed to operate. We looked for fun. We looked at what if we didn't install a battery? What if we just did solar panels? And so first off, in our modeling, we showed we might get 10% of solar PV penetration into the grid as opposed to the 30+% we're seeing now. We'd never be able to shut the diesels off completely. The diesels would have to be on all the time to form the grid. With the fluctuation in solar generation throughout the day, you simply could not count on solar being able to provide the community 100%. And sort of like I mentioned here, so the PV system, if the production drops off quickly, the generators ramp up to take that over. So they have to be online. And with solar generation alone, you can't form a grid. You can't have frequency and voltage control. Diesel generators, like I say, have this 40% minimum run point, which really limits the amount of energy, especially in the summer, that is available left over for the grid, which leads to very high PV curtailment. And by that I mean, so in the summer we have a community load of 150 kilowatts. The diesels are providing 100 kilowatts of that. The solar system, the solar array can produce up to 300, but because it's a closed remote system, there's only 50 kilowatts available. So we have to curtail that excess PV generation. It goes to waste basically. And the other thing, as I mentioned, there's no time shifting of that PV generation. The middle of the day, that's when we're getting our maximum generation. It's more than the community needs. We're able to store that in the battery and then extend the number of hours that the community runs off renewable energy. One thing I will mention is that the battery is only charged off a PV generation. It is never charged off the battery system. Here's a photo of the site. We have 1,020 solar panels. The white building is the battery building, and the green building is our E-house, we call it, or our control building, which houses the balance of plant equipment. Across the road, you can't see it, but is the diesel generating facility. We wanted to be as close to it as we can for the connection and to minimize costs there. And in the background, you can see Lake Nipigon, and the community itself is just off to the upper left. August 2019, we had our go live ceremony. Basically, we had a number of delegates from various First Nations. The entire community came out. Anyone who was involved in the community, in the project itself, was invited. All the suppliers, all the people that worked on site, anyone, the environmental scientists that did the studies early on, everyone came to witness the system going live for the first time and powering the community 100% off renewable energy. During the middle of the ceremony, which is right between the diesel generating site and the microgrid, the diesel generator shut down and the renewable energy system took over, powering the community. It worked out perfectly. In the handouts associated with this presentation, there's a link to a whole bunch of videos that were made on this project. OPG made some videos, and a couple other companies, CTV News, APTN Network. I encourage you to take a look at that handout and go take a look at those videos when you have a chance. The last thing I'm going to mention is just a bit of pride in this whole project is that the project won an award from the Canadian Electrical Association. It was an award in the sustainability category for external collaboration and partnerships, which I think, as AJ mentioned, and I will echo here, was the key to this whole project. The collaboration we had with Gull Bay First Nation and Hydro One Remotes and all the suppliers that worked on this, and Alltrade and Stantec, that was really the key for this project being successful. And with that, I will hand it off to Peter Bright to discuss some of the design challenges.
Super. Thanks, Shawn. Hi, I'm Peter Bright, Regional Sector Leader for Solar for Power at Stantec. There were many design challenges we faced for this remote microgrid system. Highlights included avoiding traditional building materials such as concrete. There was no access to local fabrication shops and other traditional construction means and methods. For example, if you needed something, you couldn't just drive down to the local distributor, Rona or Home Depot for that matter, to find what you could need. You had to use what you brought or source it locally. There were many civil and stormwater management design challenges that we faced. The site was located on a traditional spring melt runoff zone, close to the community and the lake, and the site drains across multiple driveways and local roads prior to discharging into Lake Nipigon, which the community relies on as a source of food. This site also had some historical flooding issues identified in those downstream areas. There was a requirement to match or improve those historical runoff rates. And the project was most vulnerable during the construction season, where vegetation wasn't present on the site to stabilize the soils, which of course increases the risk of erosion and sediment migrating downstream to the community and to the lake. So construction and maintenance of robust erosion and sediment control measures was key during construction. It was the key of the success in removing any of that runoff. The location also had a high water table, and during construction and the spring thaw, it presented a lot of challenges while controlling the water discharge. So post-construction rates were controlled by using a dry stormwater management facility to reduce those flows, and through site stabilization by planting vegetation in the form of native plants. There were many structural challenges we faced as well. As the site was more than 200 kilometers north of Thunder Bay, it wasn't feasible to drive a cement truck or have a concrete batch plant. So it was our project's goal to avoid the use of concrete. For structures, we needed to go with a helical pile, prefabricated off-site and shipped to this remote location to be installed. We designed a helical pile that would provide the needed support for the loads based on the frost depth, complete with a sleeve. This way the pile wouldn't heave. We also had to consider the heavy snow loads and wind loads on the solar panels and the strong winds coming off the lake. There were soil challenges too. As this location was traditionally a spring melt runoff zone, it was well treed and the soil was very silty. So we custom designed a helical pile and conducted a full on-site pile testing program with Alltrade support, while measuring the pile's ability to withstand the expected axial and lateral loads. It was through this testing that we were able to discover that the soils on the original site plan weren't strong enough to provide the strength needed at reasonable depths. So with some additional testing on site, we shifted the entire site by about 20 meters to the south, where we would find the right soil bearing capacity needed. This testing program helped us find the right location with the soil bearing capacity needed to properly support the solar racking, the e-house, and the battery storage building. Whoops. There were also many electrical challenges that we overcame in our design. This community operates on a floating neutral, where a modern-based microgrid like this needs a good grounding system for electronics and other components. So we had to come up with a way to do that. And the solution was to leave the solar array transformer energized at all times, even when it wasn't generating power. That way, the microgrid always had a good system ground to reference. And the grounding of the system was a challenge too because of the silty soils. We added some additional copper and grounding rods to achieve the proper equipment grounding that we needed, and also to ensure that personal safety requirements in the terms of step and potential safety concerns were met. Connecting the existing diesel grid station was also a challenge, and Hydro One remotes helped us, or asked us rather, to help them connect up the microgrid to their existing diesel generating system and then connect it out through to the community. There were some potential protection and control challenges as well. At first, we had a lot of nuisance tripping with the breaker due to the coupling of the two systems together, due to the imbalance of the ungrounded system. And that reference point and the sensitivity of the trip settings had to be adjusted to minimize those nuisance trips while still protecting the system. In addition, the sequence of the breaker closing operation of the ungrounded system and the grounded system rather, with the main intertie breaker also helped resolve this issue. Other challenges with this location were the extreme cold temperatures. We had to implement a cold starting energization procedure for the transformers and integrate that into the protection and control design of the microgrid. Ratings for those extreme weather conditions were also a challenge too, with the conditions with the wind and the snow and the low temperatures. So inverters, sensors, and transformers and other equipment had to be carefully selected to meet those needs. In merging new technology with old technology, there were also some challenges within the microgrid controller itself too. With regards to harmonic distortion, when we analyzed the microgrid operating under several different conditions, we observed that the second harmonic distortion was affecting the charging rate of the batteries. So we had to reduce the charging speed of those batteries to bring the distortion down to acceptable levels, and that resolved the issue. And then lastly, other challenge electrically, the microgrid controller, learning how to charge or when to discharge. The art of knowing when the batteries are best to charge and at the rates and directly feed the solar to the community instead of off the batteries was a challenge as well. And it had to be tested and commissioned on site. So through observation and testing and working together, we're able to resolve that challenge as well and come up with the best solution to meet the needs of the community. Finally, the project design had to be modeled and confirmed to make sure that the design fit the needs of the community and all aspects of the project. The first step is that we studied the location and we used historical data from the closest weather station to study the solar resources available. The next step is that we model the system, and modeling was key to make sure that we had the best solution. And in this case, it was solar. Modeling was done using PVSys and Homer, and those modeling tools were used to confirm the energy production needed to connect and supply the community. And the next step was to size and confirm the microgrid. System loads were confirmed using the connected loads, the load characteristics, and also seasonal implications of those loads. And the last step was to design the system. When designing, each solution is reviewed and confirmed to make sure it is scaled and technically sound to meet the needs of the project. And this process fits any remote application, whether it's a local community grid like this, or a mining project, or any other remote project or process. Miigwech. Now over to you, Kevin, to explain how construction-related challenges were overcome.
Thank you, Peter. Hello, everybody. Good afternoon. I'm Kevin Ritzman from Alltrade. Just a little bit about who we are at Alltrade. Alltrade, we are trustworthy constructors of specialty projects, and our core focus is building people, projects, and communities. And so that's why this project was a perfect fit for Alltrade, and we're so happy to be here, and very honored to be a part of this historic, now award-winning microgrid project. And I'm excited to share some of the challenges and lessons learned that we had on this project. So the most obvious construction challenge with these microgrids typically is the remote northern location. It throws at you a lot of unique challenges so that we wouldn't experience in other construction conditions, such as limited communications, no cell service, distance from major vendors, as Peter mentioned previously. We can't just run to around the corner to a local supplier. So you have to bring everything with you and pre-plan as much as possible. Some extreme temperature conditions down to -45 Celsius. So we had to keep equipment and vehicles running nonstop when we were working in those conditions. And then, of course, there's difficulty in securing accommodations for out-of-town workers. So you have to get unique in providing those accommodations for your team, and also minimize the amount of time on site as much as possible. So some of the solutions that our team came up with where we leveraged offsite prefabrication as much as possible. This photo down here is our e-house, and you can see some marshalling cabinets that were pre-installed, quite a few. We pre-installed those wherever possible. We were able to also incorporate the security system, the weather station, and the string inverters inside the e-house, prefabricated offsite and shipped to site. As well as you can see here, there's some transformers mounted on the front of this e-house skid, and those are the transformers for the battery energy storage system, as well as the output to the Hydro One remote's diesel generating system. We also leverage prefabrication of balance of system. So this photo up here, you can see combiner boxes as well as PV string harnesses. So wherever we could find efficiencies offsite, we did that. This is a photo of one of the guys we saw on the side of the highway. Actually, kind of a little story about being in northern locations. We had just come from the, I think it was the kickoff ceremony for the project, myself and two of my project management staff. And we had gone north to Armstrong, and we actually got a flat tire with our rental vehicle. So, you know, normally it's wouldn't be any issue if we didn't have the equipment to change the tire. We could call CAA, but you're in northern conditions. So thankfully, the rental company equipped us with that, and we were able to change the tire. So it took 2 engineers and a tradesman to do it, but we got it done. So as Peter mentioned, site geotech is a large challenge on some of these projects. It's critical to get it right. And we wanted to build this entire project without concrete. And so what we did is we went through the pile testing phase, and we encountered low torques in this area here, which is the original area that we cleared to build the microgrid. So we ended up shifting our site back. As mentioned in this photo, basically your back is to the diesel generating station, and you can see it increased the feeder size and length back to the Hydro One remotes connection, but it was a better solution versus encountering costly refusals. So you can also see some of the sleeves that were added on the helical foundations on the project. Equipment integration was probably one of the largest challenges on this project with the microgrid. We're integrating multiple systems, so the existing Hydro One remotes, generators, which you can see are interconnect here in this photo to the Hydro One remotes building. We had the ground mount solar, battery energy storage, and ABB microgrid controller all to integrate. And so really we relied heavily on, and our project management team was closely integrated with Stantec, our engineer, as well as OPG's team and their owner's engineering team to overcome these challenges. You can see a photo here of the battery energy storage system. Equipment selection. Equipment selection is always critical at design phase and procurement. So we ended up going with polar fixed tilt racking. We chose fixed tilt over single axis tracker based on the location and future O&M costs. We didn't want a costly site that would be difficult to maintain long term, so that's why we went with the fixed tilt racking there. We chose Fronius CMO string inverters, which you can see a photo of the E-house here on the left with the string inverters installed, pre-installed. And we chose those versus a central inverter to minimize system downtime. So it would be easy to swap if one inverter went versus taking down the whole system, since the community is relying on the system full time. And we ended up at the time choosing Canadian Solar 365 watt monofacial modules, which were one of the highest wattages out there at the time. And we supplied a higher wattage than was expected to exceed the generation output. And we also installed the modules in portrait, which you can see here, to minimize our balance of system costs and to optimize that design. So some critical success factors for building communities, such as this project, definitely jointly develop a community benefit plan and make sure everyone's expectations are known up front prior to starting construction, and making sure you communicate the skill sets clearly for any job postings. Early engagement with the local community energy liaison, which was AJ in our case, and that worked out very well. It was a pleasure working with AJ all the way through, as well as chief and council. They can be a real help to you for potential subcontractors and workers from the community. So definitely listen to the community and what their needs are and what they're looking to get out of the project. Host a local job fair to meet with interested candidates directly, face to face, and safety in construction. Our motto is build it safe, no exceptions. So make sure all safety requirements are clearly communicated with any subcontractors or new workers on the project. The last thing that anybody needs is an injury or an incident on your microgrid project. And as I think everybody's mentioned, open and timely communication with all project stakeholders is key. And collaboration was mentioned multiple times. So that's definitely what's required on these projects to have a successful outcome. And so kind of a spotlight for us, the bright spot on this project for Alltrade from our perspective was definitely the local community engagement. Happy to say 25% of the on-site work hours were completed by Gull Bay First Nations community member or affiliated partner. So we ended up hiring 5 workers for civil labor work, as well as rack and panel installation, and really try to train the local community up so that they can take these skill sets forward, both for O&M and future construction projects. We hired a Gull Bay First Nation civil subcontractor for clearing and grubbing the site, which was great. They knew all of the details on the project and were ready to go. We also hired a soil testing contractor for compaction testing and purchased aggregates from the local gravel pit. In the community benefit plan, we train the community for O&M on the solar farm for post-construction. And also kind of a minor detail, but also important, we use the local Gull Bay First Nations catering service for any local job fair and training events that we hosted. So overall, fantastic project, and we're really happy to be a part of it. With that, I will hand it back to Justin for questions.
Thank you, Kevin, and thank you, everybody. So we have a few minutes for some questions. So the first one actually is for AJ. Are there future plans to replace diesel generators, biofuel generators?
We're working on a feasibility study right now to check into bioheating. I don't know if we're going to do it for the providing more power to the community, but we definitely want to look into renewables, whether it be small hydro, more solar, or wind. We want to bring that 25% up to 100% renewables, because our goal is to be 100% off diesel, with using diesel as a backup. So that's the goal, but nothing really substantial. We kind of are in the mode of, since we own and operate this now, let's get comfy with that. Let's get let's get comfy with operating this and see how it goes for the first year and happen, and look at some feasibility studies for other renewables.
Okay, great.
Good question. Thank you.
Thank you, AJ. I'll set it whoever wants to answer this one, I guess. What prevented 100% solar battery solution as part of the initial project? So, Shawn, you want to take this one?
Sure. Well, the obvious answer is just cost. We're talking, up northern Ontario, middle of winter, you can have days without any solar generation. So you'd have to build a solar facility large enough and have a battery system large enough to be able to charge that up to be able to provide the community with days of power. And that's an extravagant cost that would get used, rarely. So it just it came down to cost. You just simply can't afford to do that.
Okay. Another question we have, and just put up your hand if you want to answer this one. What is the variation in current output from the PV array for changes in weather?
I'll take a crack at that. I've been looking at the operation of it. So one of the things we've seen is you can get a windy day up there, sunny, a cloudy day, and PV generation can go from almost max of 300 kilowatt output down to 50 in a matter of minutes if you get a very cloudy, windy day. So it is very variable, redundant there, and that's the real key to the battery system. You be able to smooth out PV production.
Okay, great. Thanks, John. So this one's for Peter. What battery chemistry was used?
They are lithium-ion batteries, and in the battery building provided through OPG. I think the ABB batteries, Shawn, or what were they again? I forget offhand.
Yeah, it's an ABB system. Battery modules themselves were Samsung.
Samsung. Okay, thank you.
Okay, great. Again, if anybody wants to take this one, what was the runtime of the genset after the battery storage was installed?
I guess I'd like a little further. What do they mean by runtime of the genset?
I don't know. Just a question is after the solar battery were installed. So if somebody wants to add some more details to the questions, we can run back and get that one. Okay. Maybe this question's for AJ. Have other communities reached out to Gull Bay for lessons learned?
Yeah, some communities have reached out, and I was able to share some information. But I do want to mention though that we plan on having an off-grid diesel boot camp in the community where we can share, loads of information to Indigenous communities that want to come and visit post-COVID, of course, to learn what we learned through this process. In some communities, I was able to share whatever I could through the emails or through phone conversations, as well as through various presentations that I have been doing within the last few years. But that's the big one. The off-grid boot camp is what we're planning is going to be loaded.
Great, thanks, AJ. I guess we'll go to Kevin. What was the worst risk that was identified, and how did you plan to mitigate it, and was it realized?
Yeah, I think on the front end, the geotech risk from a construction standpoint was one of the largest risks. I think the biggest risk was the integration of all the equipment, and yes, it was realized. How did we mitigate it? We fought our way through it. With Stantec's help, OPG's help, collectively, I think that's was probably the biggest challenge that we faced on this project, was integrating all the multiple systems.
Okay, great thinking. So we're at 12:59, and I do see there's still several questions there. So what we'll be doing is some of our experts on the panel will be able to respond to you that way. There's some excellent questions. But really, since we're at the end of the time, I just wanted to thank our speakers, AJ, Shawn, Peter, and Kevin, and of course the team behind the scenes to put this webinar together. I also want to thank you all for joining us. We had a great attendees and a great registration. I hope you did find this of value. And really a plug for Energy Storage Canada. We look forward to seeing you at our annual conference in September, on September 29th and 30th. So mark your calendars and look for details on that. We'll be putting on similar great informative panels. So thank you again for joining us, and have a great day.
Thank you.
Thanks, everybody.
Take care. Bye-bye.
Yeah.